Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Okay, let's try this one. Prove using induction that for all n is an element of n, the sum of the first n square numbers can be found using the formula 1 squared plus 2 squared plus 3 squared plus 4 squared put ... plus n squared equals n times n plus 1 times 2n plus 1 all over 6. Okay, so if we remember our steps. Okay, this is our statement. This is our P of n. Okay, so we're going to show true for n equals to 1. Okay, so I take my first term off this side, which is 1 squared, and I'd like to show that's equal to P of 1, so n takes on the value of 1. So 1 times 1 plus 1 times 2 1s plus 1 over 6. Okay, so that's 1. 1 and 1 is 2, 2 1s are 2 that's 3. 3 by 2 by 1 is 6, so 6 over 6 is 1. So I'm getting here that 1 is equal to 1. Therefore, it's true for n is equal to 1. Okay, step 2, assume true for n is equal to k. Okay, so P of k then, 1 squared plus 2 squared plus 3 squared plus ... plus k squared would be equal to k times k plus 1 times 2k plus 1 all over 6. Okay, so that's our assumption that we're going to use when we prove true for k is equal to 1. Okay, so our next one, prove true for n is equal to k plus 1. Okay, so my left-hand side becomes 1 squared plus 2 squared plus 3 squared plus ... plus k squared. So I build from here. So I leave the k squared there. And k plus 1 is one term up from k. So the next term up from k is k plus 1 squared. Okay, and on the right-hand side, all of these k's will become k plus 1s. So he'll be a k plus 1 in my second bracket, or in this bracket here, he'd be a k plus 1. So I'd have a k plus 1 plus 1. And in this one, it'll be 2 times k plus 1 plus 1 all over 6. Okay, so I hope that bit makes sense. Just like we've done for any of the other sum of a series ones, we're going to use the assumption we made for n is equal to k and substitute that in for the sequence up until k squared. Okay, so all of this I'm going to replace with this. So on the left, I'll have k times k plus 1, 2k plus 1 over 6 being equal to, let me tidy up the right-hand side, k plus 1, k plus 2, and here I have 2k plus 2. So I'll end up with 2k plus 3 in that one, all over 6. Okay, I'm just going to go to a new page rather than try and squish it in. So let me take down that line again. I had k times k plus 1 times 2k plus 1, and I made a little error on this page. Let me show you what I did. Move him back a little bit. I forgot to add on this bit on the left-hand side. Okay, so I have k plus 1 squared there as well. Okay, and on my right-hand side, I had k plus 1, I had k plus 2, and then I had a 2k plus 3 all over 6. Okay, So we subbed in for n is equal to k for that one. We have the extra term here, and then we've worked out what the k plus 1 version of the right-hand side looks like. Okay, so again, you have a few options here. You must make the left-hand side look like the right. I'm going to get a common denominator here on the left. So k times k plus 1 times 2k plus 1 plus 6 times k plus 1 by k plus 1 all over 6. Okay, so instead of k plus 1 squared, I just wrote it out as k plus 1 by k plus 1. Okay, let's have a look now. I need this side to look like him. You can do it through algebra. You can work out, actually multiply out both sides. What I'm going to do, I think, on this one is factor out the k plus 1, because that appears twice. Okay, so I'm left with k times 2k plus 1 plus 6 times k plus 1 there, all over 6. And I have a k plus 1 there already. That's why I factored it out. And then I think I'm going to multiply the rest of it by each other. Okay, so I'm going to multiply this out, I'm going to multiply this out, and hopefully the left equals the right. Okay, so let's try that. Let's see where we get. I have 2k squared plus k plus 6k plus 6 equal to k plus 1 times 2k squared plus 3k plus 4k plus 6 all over 6. So I have k plus 1 times 2k squared plus 7k plus 6 all over 6 being equal to k plus 1 times 2k squared plus 7k plus 6 all over 6. Okay, and the reason I just didn't multiply it out is just because it's quite long. So I left the k plus 1 there because it was quite a common one on both sides, and just multiplied the rest out. Okay, so now I can say that the left-hand side equals the right-hand side. Therefore, p of k plus 1 holds true, assuming p of k is true. Okay, we also showed that p of 1 is true. Therefore, we've shown the smallest, we've shown the general number and the number after it. Therefore, we can say p of n holds true for all, how do they write it? N is an element of n. Okay, so that was one of the harder ones I could find on the sum of a series. I hope that was okay.
If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.